Okay. Okay. So today what we're going to be talking about is the 4 fundamental components of a DAX measure. Really, we mean the 4 fundamental components of DAX, but we'll just talk about a DAX measure this evening. Okay. So to set the stage a little bit, what I want to talk about or just show you is this right here. So imagine that you've got a report, and on this report you've got a visual, and on this visual you've got total sales and premium product sales broken down by year and state. Okay. So when you've got this table right here, when this table is sort of inception occurs and it's first born, right? There's several filters that are being passed in automatically to create this table. Those filters are any slicers that have slicer selections on them, like here for store layout or product line. It includes anything over here on the filters pane, like we've got category as food selected. It also includes things like cross-filtering. So somebody's clicked on Q2 over here. All of those selections create the initial filter context for a visual like this, okay? So those are the initial filters for this visual. The next question becomes, well, wait, how does everything else get built? Okay, because if we think about a number, like this number right here, this 79,000, for that number to be populated, right, what we need filters for both state equals Washington and year equals 2016. And I just told you that the filters that are in place when this filter starts being born are all these green ones out here, and there's no filters for state or for year, okay? So where do those filters come from? Obviously, they get produced, but how? That's what we're going to be talking about today, and also all the different ways and the components that go into making a measure. Okay? So, ask a question. Would you like to understand DAX? Yes, good. Okay, I've got about an hour. Yeah. So, refine filters, derive table, iterate. Those 3 things. Those 3 concepts are the fundamental building blocks of DAX. 95% of the stuff that you can do in DAX comes from different combinations of those 3 components right there, right? Refining filters lets you target the rows that you want to work with. Deriving table pulls the values out into a table value that you can work with. And an iterator, it takes that table value and makes something more useful out of it. Those are the only 3 things you need to know to understand DAX. Okay, so let's talk about some tables. So up here, I've got 2 tables. Up here at the very top, I've got a summary table like you might see in a visual, right? So we've got broken down by month, we've got total sales, Oregon sales, prior month sales. So that summary table there, that summarization is summarizing a table in the data model. Specifically, it's summarizing this table right here, where we've got quantity and unit price broken down by month and by state. Every single transaction we've got a row for. Okay? All of these summaries come from right down there. And the way we produce them is some combination of refining filters, deriving tables, and iterating. Sound good so far? Nodding heads. Good. Okay, so let's ignore the summary table for just a second and look at the table in the data model. Just think about it. Okay? So at any given moment, you're probably not going to want to look at all the rows in this table in the data model. You're only going to want to look at a subset. So for example, you might want to just look at the sales transactions for January, month 1. Maybe you just want to look at the sales transactions for month 2, February. Maybe you just want to look at month 3. Or maybe you want to look at all the transactions related to Washington. Maybe you want to look at all the transactions related to Oregon, right? Maybe you want to look at all the transactions related to Washington in February. Regardless, for any individual cell, you're probably going to want to look at some very small subset of the data. You're not going to want to look at the whole thing, just a subset. Does that make sense? Good. Okay, so how do you do it? Right? So if we think back here to this summary table and we look at this Oregon sales transaction, let's think about how we get those filters in place. Okay? So there's this concept of a filter context. The filter context is what lets you look at different subsets of the data. Is my mic still working? I didn't just pull it out. Fantastic. Okay. So the filter context is a set of tables that acts as a lens. And when you look through that lens, you see different subsets of the data. You see different single individual rows. Not all of the data, just a subset that you care about. Okay? So if we think about this cell right here for Oregon sales for month 2, right? What are the filters that we need for this number to be correct? Well, we're going to need a filter for Oregon, and we're going to need a filter for month 2. And if we look at our filter context, right now it's empty, which is why we're looking at the entire table. Okay? And that's where filter refiners come in. A filter refiner is a thing in DAX that creates a new filter context so you look at a new, presumably better subset of the data. So when we start to run that measure, the very first thing that measure does, because all measures are filter refiners, is it refines the filters. Right? The first thing it does is it says, I'm going to perform what's called current row filtering, also called context transition. So I'm going to go look and say, hey, any categories that are in the current row of this cell, like for instance, month equals 2, I'm going to add those as a filter. And that's what it did right here. Here's the old filter context. The filter refiner said, I'm going to take any values in the current row. I've got one for month 2, and I'm going to add it as a filter here. And now in this new filter context, I'm just looking at month 2. Okay? So this in here, this is a table. In DAX, filters are tables. So when we're adding filters to the filter context, we're doing them as tables. Okay? But we're not done yet, right? What's missing? Are we looking at the right rows? I just told you we're not. What should we be looking at if we're trying to get Oregon sales for February? We got February. What else do we need? Oregon. Very good. Okay. So in order to get that, we need to change the filters one more time. We need to refine them again. So in the measure, we're going to call another filter refiner to modify the filter context, create a new one that's more accurate, right? So we'll refine filters yet again, and we'll add a filter for state equals Oregon, and now we're looking at the right subset of the data. Now, we're not done. We still have to pull those values out, and we still have to perform our calculation. But before we can do any of that stuff, we have to look at the right rows, okay? Does that concept of filter refiners make a little bit of sense right now? Doesn't have to be perfect. Doesn't have to be crystal clear. Yeah? Okay, good. So let's look at another example. Let's look at previous month sales, right? When this cell starts, again, there's no filters in the filter context because no slicers are selected, right? But what are the filters that we need? Well, if we want previous month sales for month 2, we should have a filter for month equals 1. That's how we're going to get the right answer, right? Okay, so when the measure starts, the very first thing it does, because measures are filter refiners, is it adds any value of the current row as a filter. Well, we've got a value for month 2, just like before, right? So when that measure starts running, the filter refiner kicks off and it adds a filter for month equals 2, just like last time. But we don't want month equals 2, we want month equals 1. So through a little bit of extra work, through some combination of table derivations and iterators, we're going to create a new filter refiner where we modify the filters one more time. We remove the filter for month of 2, and we add a filter for month of 1. I'll show you how to do it later, but generally that's what we're going to be doing, right? We change the filters to look at the rows that we care about. Okay, still making sense? Good, okay. That's filter refiners. By the way, those are the hardest part of this presentation, is understanding all these slides so far. Everything after is a little bit easier. You can tell me if I'm lying, but I think it's easier. Okay, so I want to mention that what are filter refiners? Filter refiners are a thing that create a new filter context, right? Via either current row filtering, which is to say take any values of the current row and add them as filters, or override filters, which is where you as a DAX author specify, I want to override the old filter context with this new filter that's more correct, right? What are the filter refiners? You've got calculate, calculate table, and any measure. Those are the only 3 you guys need to worry about. Okay? So that's filter refiners. So once you're looking at a certain subset of the data, you might want to actually do something with it, right? What with this being a tool and all. So what do we want to do with it, right? So right now we're looking at month 2 and state equals Oregon. I'm going to want to pull those rows out so that I can work with them. Because all the rows in a data model, you can't actually work with them directly. If you want to work with that data, you have to pull it out into a table value. That's what a table value is. So I might do something like this, right? I'm going to derive a table. In the code, I'm just going to write sales because this is the sales table in the data model. And what am I going to get? Am I going to get the entire sales table? No. I'm only going to get the rows that are visible through the current filter context, right? So if I've got a filter context with month equals 2 and state equals Oregon, well, I'm only looking at those rows, so when I ask for the sales table, those are the only rows that I get. Does that make sense? Good. Now, I'm going to be able to do stuff with this in a second using iterators, but before I could do something with it, I have to pull it out, right? I'm extracting those rows, okay? But that's not the only table derivation that I've got. I've got a whole slew of them, right? I can also say something like values of a single column. So right now, I'm getting the values of the state column, and what is this going to show me? It's going to get me all the distinct values that are visible in these rows. So if I look here, if I look at the entire table, I've got Oregon and Washington, but if I'm only looking at the visible rows based on my filter context, all I've got is Oregon. So I derive this table right there. And once I've got it, I can go do other stuff with it using an iterator. Okay? Now there's other table derivations. What if I want to ignore the filter context? You can imagine somebody looking through a camera. They want to peek outside of the camera to see the entire field, right? You can also do things like use all of a column. So if I say all sales state, I don't get all the values that are visible for the state column. I get all the values, visible or not. It ignores the filter context temporarily, right? So I could go get all those values. Okay? Now, what if I don't want all the distinct values of a single column? I want all the values of all the columns. I can also say all sales. And I even run out of screen real estate, right? But this is ignoring the filter context. It's getting all of the rows and pulling them out into a table value so that I can work with them. Okay? Those are the 4 derivations that you guys have to worry about. There are more, but these will get you to do almost anything you need in DAX. Okay? So once you've derived the tables, oh wait, not done yet. So table derivation creates a table value based on a physical table in the data model. You can just refer to the table and get all the visible rows. You can get all the visible values of a single column. You can get all the values of an entire table, or all of the values of a column ignoring filters, right? That's a table derivation. So I'd like to point out that at any given moment, you only have one filter context at a time, right? That's sort of a rule of DAX. But if you just imagine 3 filter contexts, maybe this one happens after this one, happens after this one. If you imagine these 3 filter contexts, within every filter context, if you perform the same table derivation, in every single one you ask for sales, sales, sales. Even though you've written the same exact word, you get 3 different table values. Why? Because you're asking under 3 different filter contexts, right? So in this one, you get all these rows because that's what's visible by this filter context. In this one, you'd get all these rows because that's what's visible under this filter context. And in this one, you get all these rows. In fact, just this one row, because that's all that's visible given this particular filter context, okay? Same derivation, different values based on the filter context. That's why we change the filter context, so that we get different table values. Okay. So, talked about table derivations. Let's talk about iterators, right? These are the workhorse of DAX. So, we've pointed at the rows that we care about. We've pulled them out into a table value to do something with them, right? The iterator is going to be our manufacturing process. It's going to let us create a new value off of that value that we've created. So, an iterator might do something like this. I might say sum x of this sales table right here, right? And then I've got all this gobbledygook right here. So what is an iterator? What does it do? Iterators are all fundamentally the same. They'll take a table value, add an expression column to it, and do something with that column, right? So in this instance, the iterator is sum x. It takes this table right here, the one that we're pointing at right here. It takes that table and adds a column to it, right? What's the definition of the column? That's argument 2. So we say, hey, we're going to create a new column where for every single row we get the quantity and we multiply it by the price. And sure enough, for every single row we've got quantity times price, quantity times price, quantity times price. Those are all those numbers right there. What do we do with this new column? We sum it up because we're using sum x, right? That's an iterator. That's what it does. Okay? Does that make sense? Good. Okay. So I'm going to, for shorthand purposes and shave on space, I'm going to write these iterators like this. I'm not going to put sales in there. Just put sales right in there in your mind. Make it a little bit easier. So as you may have guessed, there's multiple different kinds of iterators. So let's look at some different iterators. Right now we're looking at sum x. We could also use max x. Now in this max x, I'm using the exact same expression. For every single row, I'm still calculating quantity times price, right? So I get all the same numbers right here. But why? I get a different answer because we're using max x rather than sum x. So rather than summing up these values, I take the max of them, right? I could also do average x, right, with the same exact expression. I still get the same cells right here, but now I'm averaging those values to get 21. Forget what I wrote there. That's a typo. That's a typo. Bonus points if you find all my typos. They're there to make sure that you're paying attention. Okay, so previously we showed you all the different iterators. What if we use the same iterator, but we change the expression? We change argument 2, right? So in the first one, we've got sum x of sales. We're adding quantity times price and adding it all up. We can also do just quantity. For every single row, just give me the quantity and add it up. That's pretty easy. I could also do goofy stuff. Like for every single row, if the sales quantity is greater than 3, go ahead and add 1 to it. Maybe it's like a baker's dozen. They give you an extra donut at the donut shop, right? Otherwise, just do the regular quantity, right? I can do whatever I want to. It's just any value that evaluates to a single scalar, single number, right? And then what do I do with it? I sum it up, right? Okay. Yes. Take the mic.
I just want to clarify. I just want to clarify that what you're saying is really from here to here is everything that happens between a bracket and a DAX measure, right?
That's right.
So this is not a slicer happening outside, right? This is really because you have a matrix and it's a summary query that a filter refiner kicks in. So when you wrote the measure sum x, by virtue of it being a measure, all of this starts and ends with iterator. Is that right?
Yeah, and you don't. The most common process is to refine the filters, to derive tables, and iterate. You will see that over and over and over again. There's actually different combinations. You could refine the filters, derive a table, then refine the filters again without using any iteration. You could use them in lots of combinations. This is just the most common, and this all happens inside of a measure. And inside of a measure, 95% of the time, you're just using these 3 things. That's what we're getting at. Still clear? Okay, good. So I'd like to point out, right, that you could do silly stuff, right? You could do sum x of pi. For every single cell, I calculate pi and I add up the results. Turns out 3.144 times is 12.5 seconds. Who'd have thunk it, right? I could generate a random number between 20 and 30 to get 100, to get all these numbers and add them up to get 101. I could take the month number and multiply it by the price. My point with all this is as follows, right? The rules of your business are important. The rules of DAX are important. They are not the same rules, okay? So if you want to become a DAX expert, you have to be able to hold both sets of rules in your head independently. And you have to make sure that you are not constrained by business rules when you're thinking about DAX, because DAX is it's a whole own engine, okay? Two different things. Okay, so there's one other special iterator that I want to talk about. We talked about sum x, average x, min x. Those work about like you'd expect. There's also this iterator called filter. It doesn't have an x on the end of it, but don't be fooled. It is an iterator, right? And what does it do? Well, we've got filter, sales price equals 5. We've got a bunch of trues and falses. So what does it actually produce? What it produces is a table value. It produces a table value of all the rows where we got a true, right? So we asked, is the price greater than 5? Well, let's see. For here, price is 10. That's true. That's true. Those are false. So we only keep these rows right here. We produce that table value. That's what you do with filter. Another example of that, we could just say, hey, is the quantity greater than 2? Well, those are these two rows. So those are these 3 rows. So those are the rows that we get out of the filter function. We could even say something like, hey, something complex, like if the quantity equals 4 and the price is equal to 10, just keep those rows. We get 1 true, so that's the 1 row that we get. Okay? That's how we could use an iterator to create a whole new value, not just a scalar, not just a single number, a whole new table value. So you might be asking me, Brian, why would you want to do that? The short answer is you could take that table value, you can pass it into a filter refiner. Just like that. You use that table value in combination with the filter refiner and say, hey, that's my new filter. My new filter is now this row and this row. The state has to be equal Oregon, month is 2, quantity is 4, price is 10, or the state is Oregon, month is 2, quantity is 3, price equals 6, which shockingly just points to those 2 rows right there, right? So when you want to modify the filters in some complex way, you're going to use this. You're going to derive a table. You're going to use an iterator. Then you're going to use filter to create a subset of those rows that correspond to the new filter that you want to create. And I'm going to show you an example of that too. Yes?
So how do you handle kind of like a copy end where the sequencing and then you're selecting from that? Can you do that with selected?
So there is a top-end function, yeah. I mean, again, anything that you could calculate and be persistent in an actual cell or a row in a table, you could use in a top-end function. So assuming you could pull that off, yeah, you could definitely do that. Okay. I might ask you for an example after the whole presentation just so I could dig in a little bit deeper. Does that sound fair? Okay. All right, so we've got our filter refiners, we've got our derived tables, we've got our iterators. Those are all the tools that we need, right, to do DAX, to create DAX measures. Let's go look at some examples. Does that sound like fun? Yeah, sure, why not? Okay, I was hoping if everybody said no, we'd have to stop. That'd be terrible. Okay, so I'm going to make some room for myself, right? And I'm going to bring back my pivot table up here, like I had before. I've got total sales, Oregon sales, and previous month sales for month 1, 2, and 3. Okay, so let's look at a couple of these, right? Let's look at this number right here. This is total sales for February. Now I'm going to write the code over here just so you guys can see it, but don't focus on the code. Focus instead on this stuff over here, right? We're going to record this. You can come back and watch it again. For now, worry less about the actual code and worry more about understanding that structure of refine, derive, iterate, okay? So we're going to be producing total sales. How are we going to produce it, okay? So when this measure kicks off, the filter context is empty because there's no slicers active. So the very first thing that it does, because a measure is a filter refiner, it refines the filters. Any measure. There's no measure that doesn't do that, okay? So total sales refines the filters, looks for values of the current row. There's one as month equals 2. So it adds that as a filter. Hey, we've refined the filters. Now we're just looking at all the rows where the month equals 2. Cool. Hey, you know what? For total sales, that's all the refinement we need. We can go ahead and derive a table, right? What are we going to derive? We're going to derive sales. So we go pull out these rows in the data model. There they are, right there. And when we're done with them, we're going to get the total sales. How are we going to do that? Well, why? With an iterator, of course, right? We use the sum x iterator. We say, hey, for every single one of those rows, I want you to take the quantity, multiply it by the price, and then take all those values and sum them up. Why do we sum them up? Because it's sum x. Why those values? Because that's the argument 2 right there for every single row, quantity times price. And that 112, well, sure enough, that's our total sales. Okay, that's how it works. Questions about that? Yes? Oh, gotta wait for the mic.
Sorry, this is my first time.
Please, yes.
I'm a SQL developer. So, this comes from the, I guess, trying to translate your language.
Yes.
So, in a stored procedure, you have input parameters.
Yeah.
So, can you translate, can you understand my language? Can you do input parameters for this?
No, it doesn't work the same way, and that becomes kind of a challenge because DAX sometimes looks like SQL, but it's fundamentally not. Anybody that's more familiar with DAX want to do a better job translating that up for me? We're more familiar with SQL? Yeah. No, a measure does not take, well, because a measure is a filter refiner, you can technically provide override filters, but they're not parameters. It's not exactly the same thing.
Yeah,
So no is the short answer. What's that?
What is it in your language, or it just doesn't?
What is a measure? What is a parameter or a store product?
What would be analogous to an input parameter, or it just doesn't do that?
Doesn't really exist. What's that?
Well, are you saying for an input parameter, are you saying like a where clause, where, like a condition where color is red? Is that what you mean by an input parameter on a SQL statement?
Forgive me, one on you, two on a SQL developer. We have taken one Unity class in this, and they did something like, they put a bunch of graphs up on the screen,
Uh-huh.
and let's say there were different states, like Oregon, Washington,
Mhm,
Idaho, whatever, and you clicked on that state, and then something changed in the other thing.
Yes.
And so, is that called a slice?
It's a slicer. It's slicer or cross filtering.
Can you click on like a state, like, and then have that be like an input parameter?
You could think of,
The measure.
it's going to be an input parameter to the summary query or the DAX query that's being written. You can try and detect it, and in that sense, it can act like a parameter. Like, so you say, hey, go check to see if state is filtered, or more specifically, check to see if state is filtered and the only value in state is California. And if it is, then you can have it behave a certain way. So in that sense, you could sort of trick it into acting like an input parameter, but it's not quite the same thing. You can't specifically ask, hey, was there a parameter passed in, and can I like use it for something?
So that would be like more advanced DAX?
Yes, it would, yeah. Uh-huh. Yeah. It's a great question, though. Thank you for asking it. Yeah. Other questions? Okay. So let's do round two. I think each time we do it, it might make a little bit more sense. A little bit more sense. Okay. So now let's look at Oregon sales. Okay. So what filter should be in place for Oregon sales? For this cell right here, well, probably month equals 2 and probably Oregon. Otherwise, we're going to get a phone call, right? Okay, so how do we do this, right? When the measure starts off, because the measure is a filter refiner, all filter refiners always perform current row filtering, or context transition, if you're familiar with the Italians, right? So is there a value in the current row for a category? Sure there is. Month equals 2. The very first thing this measure does is refine the filters to add month equals 2. Now we're just looking at February, okay? But we're not done. We can't just look at February. We also have to look at Oregon, right? So how do we make that work? We do it with the following. Same pattern as always. We're going to derive a table. This time, right, we're going to derive all the values of state, okay? So we're going to say all sales state. This is going to give us all the values of state, whether they're visible or not, right? So we don't just look through the lens. We look at everything. Say, what are all the values of state? It turns out there's Oregon and there's Washington. So we pull those out into a table value to work with, okay? So once we pull them out into a table value, right, we just want to look at Oregon because the name of the friggin' measure is Oregon sales. So how do we do that? We use an iterator, okay? So we use the filter iterator just like I showed you before. We say filter, we take this table, and for every single row we ask, is the state equal to Oregon? Is Oregon equal to Oregon? Sure is, so we get a true. Is Washington equal to Oregon? Sure is not, so we get a false. So what do we actually keep? This whole statement right here returns this table, state equals Oregon, right? Then what's the next thing that we do? We use a filter refiner, of course, to take that state value and add it as an override filter, right? We use the calculate statement, which is the other filter refiner that you use all the time, right? We say calculate, I want to go run this expression, but before I do, I want to add an override filter, specifically this override filter right here. So it takes the previous filter context and adds Oregon to it. Now we're just looking at February and Oregon, the way we wanted. Okay? The path forward is pretty simple. Just like before, we derive a table. We go get the sales table. Here's all the rows in the sales table that are visible in this new correct filter context, right? We use an iterator. Specifically, we use SUMX. So we take that table. For every single row, we calculate the quantity times the price. We get the sales for each line, for each transaction. We add it all up to get $82, and sure enough, there's our $82 for Oregon sales. Okay? Making sense? Anything fuzzy? Question? Oh, gotta wait for the mic. Sorry.
Is it really necessary to do all those two steps? I mean, couldn't you have just gone?
Yes. So,
Just then calculate, and then state equals Oregon.
yep.
Blah, blah.
Yes, you can. So that brings up two good points. The first one that I'll address is that in the DAX language, they've included a lot of, they call it syntactic sugar. I refer to it specifically as DAX contractions. By that, you can write something in a short, compact format that the DAX engine actually translates to a longer format, right? So if I write something in DAX like calculate total sales state equals Oregon, that state equals sales is actually translating to all this junk right here, right? It's not written out for you, but it's there, right? Because state equals Oregon doesn't actually make sense until you turn it into a combination of table derivations and iterators, right? So that begs the question, should you write it this long way? And my answer would be, if you're new to DAX, I recommend doing it this way, just so you can get in your head exactly what's happening mechanically. Once you've got that pretty well established in your head, go ahead and write it the short way, because it's a lot faster and more compact. Does that answer the question pretty well? Good, 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 good.
I
Yes.
just want to sort of elaborate
Oh.
on that. One of the most challenging things about DAX is that a filter is a table, right?
Ah.
I kind of say that to myself about 80 million times. A filter is a table, especially if you come from a SQL background.
Yes.
Where you say a filter is a where conditional clause. You know, I'm going to filter where state equals Oregon. How is a filter here a table? But so a big part of presenting it this way is you start to think of the table filters as tables.
That's absolutely correct. Yeah. If you can't think in terms of filters as being tables, it's like going to a foreign country and not learning the language. If you've got a little translator book, you can kind of get by. But if you really want to talk to the DAX engine thinks in tables, so you have to be able to speak to it in tables. And if you can think in tables, even better, right? More or less cover it? Cool. Okay. Other questions before we go on to our last example of the night? Okay, one more. Okay. So let's look at previous month sales, right? So we're looking at previous month sales for February. So what should I get? I should probably get the sales for January, right? That's what the previous month was. But how do we get it? Well, we've got all this code right here, but all this code is just going to be a combination of filter refiners, derived tables, and iterators. That's it, okay? So when we start out, previous month sales, all measures are filter refiners. So filter refiners do two things. They could perform current row filtering, which they do automatically, and you can optionally provide override filters. We don't provide any override filters in the code, right? So we're just going to do current row filtering. Because this cell is in month equals 2, the filter refiner adds a filter for month equals 2. Now we're just looking at February, which is perfect, except that it's wrong, right? We need to be looking at January. So how do we make that happen, right? So the first thing we're going to need to do, in the previous example, we knew we were looking at Oregon, right? So when I did my override filter, I knew to look just for Oregon, but I have to figure out what month I'm in before I could figure out which month to go to, okay? So I'm going to start by figuring out what month am I in. I'm in month 2, I can see that. DAX has to figure it out. How do we do that? Again, derived tables and iterators. So we're going to start by getting all the values of the months visible in the current cell, right? So values, sales month, and how many visible months are there? Well, in the entire table there's 3, but in the part that we could see there's only 1, right? So we get month equals 2. Okay, so then we use an iterator to say, all right, let's take that table right there. Let's perform the following iteration. We're going to do max x. So take this table of 1 row, right? And for every single row, take the month and subtract 1. So if we take 2 and we subtract 1, we get 1, right? And if we take the max of that one single value, what do we get? 1, which happens to be the previous month. Now we know what the previous month is. Okay, cool. Now that we've got that, let's go do the following. Let's go get another table derivation This time we're going to get all the months. So instead of doing value sale month to get all the visible ones, we're going to do all sales month to get all the months, regardless if they're visible or not. Okay? And once we've got that, we use another iterator to say, hey, I'm going to take that table, I'm going to use the filter iterator. So take that table and add an expression where I ask, hey, is that month equal to my month hint? That month hint is this 1 right here. We just got it a second ago. And it's going to be different for every single cell, right? So for this particular cell, we get all the months. We say, is 1 equal to 1? Sure is. Is 2? Nope. Is 3? Nope. So we keep that row right there. That becomes our new table. And what do we do with that table? We pass it into a filter refiner, right? To get our filters just right. Okay? So down here we use the calculate function, which is the other major filter refiner. There's measures in calculate, right? So we're going to take calculate, pass this table into it to modify the filters, to add a filter for month equals 1. Now notice there's already a filter in there for month equals 2. So what happens if there's a conflict? DAX says, well, you said month equals 1, so I assume whatever was in there before is no good, right? So it removes the filter for month equals 2 and adds a filter for month equals 1. It's that table right there. And now, sure enough, again, we're looking at the right rows. January. This is exactly what we need for that calculation right there. So at this point, what do we have to do? Pretty simple. Derive a table. Just like the other 2 examples, we get the sales table visible in this filter context. That's those rows right there, the rows for January. We take those values, we pass them into an iterator. Just like before, the iterator is going to be sum x for every single row. We're going to take the quantity, multiply it by the price, get those values right there, and what do we do with them? We take the sum, because it's sum x. If it was average x, we take the average. If it was max x, we take the max. But we want sum. So we sum all those values up, we get 136, and that's how we get $136 right there. Questions about that? Okay, so we've seen a lot of stuff today, right? But it's important to remember all of that stuff comes down to 3 things. Refine the filters, derive tables, and iterate. Target the rows you want to work with, extract them out into a table value, and use an iterator to manufacture a more useful value, either a number or a table to pass into a filter refiner, right? Just those 3 things. What is a filter refiner? It creates a new filter context via either current row filtering or optional override filters. The filter refiners that you use 95% of the time are calculate, calculate table, and any measure. You can derive a table once you've refined the filters to go pull values out into a table value for you to work with. There's many table derivations, but there's 4 you're going to use over and over again. You can ask for the table by name, in which case you get all the values that are visible in the current filter context. You can use values to get all the visible values of a single column. You can use the all function pointed at a table to get all the rows of a table, ignoring filters. You can also use the all function to point at a single column to get all of the values of a single column, ignoring filters. Those are the table derivations that you're going to need. And once you've got those, you use an iterator, right? An iterator creates a new value from a usually derived table value. The new value is based on the action of the iterator, which is to say, what is its name? Sum x, average x, max x, average, sum, max. And it's based on the defined expression call, whatever you pass into argument 2, to say, what is my definition for that new column? And that's it. Now, this isn't everything in DAX, but for a new user, this is everything that you need. You can do 95% of DAX with these 3 things. There's more to learn, don't worry. And don't worry, this still gets hard, but it all does boil down to this. Okay? So with that, I'm going to ask, any questions? All right, free pizza for everybody, or whatever's left. Thank you very much. Thanks for your time.